Okay, business algebra. We talked a little bit about matrices in the last section, and I said we would get to more moving forward. And here we are, but this is a little bit of an easier section than the previous one, so that's not bad. So matrix addition and subtraction. So the matrix size is referred to as m by n, where it's the number of rows by the number of columns. So for example, the matrix you see here, 2, 3, 4, 5, 6, 7, is 2 by 3 because it has 2 rows and 3 columns. A matrix that's only a row is called a row matrix. A matrix that's only a column is a column matrix. And if they're the same, they are called a square matrix. When talking about a matrix, it's important to talk about individual entries of a matrix. So how can I call upon, say, the 6 or the 7 if I want to talk about that specific entry? We use subscripts for that. If you see A13, really should be little a, but that's okay. So it really should be little a13. That refers to the element in matrix A in the first row and the third column. In that case, first row, third column is the 4. Every element will have a unique number associated with it. The general form of this is again Aij, where I refers to the row and J refers to the column. Matrix addition, pretty simple. Two matrices can only be added together if they have the same number of rows and columns, so they're the same size. And then you just add or subtract the corresponding elements. So if they're in the same place, you add the numbers together. So for example, 2, 3, 4, 5, 6, 7, plus 5, negative 1, 0, negative 2, 5, 1. You just add the things that correspond to the other in the exact same location. That's it. If they don't have the same size, you simply say, well, we can't add these. And that's it. Okay, so let's practice this. 5, negative 6, 8, 9, plus negative 4, 6, 8, negative 3. Are they the same size? Yes. So my solution is 5 plus negative 4, negative 6 plus 6, 8 plus 8, 9 plus negative 3. That'd be 1. 0, 16, 6. That's simple. B, can I add 5, 8, 6, 2 and 3, 9, 1, 4, 2, 5? Not the same size, so no. So you cannot add them. Subtraction works exactly the same as addition. If they're the same size, you subtract components. So in A, they are the same size. So you have 1 minus negative 2. 0 minus 1, 2 minus 3, negative 1 minus negative 7, 3 minus 0, and 5 minus 2, which is 3, negative 1, negative 1, 6, 3, 3. B is the same size again, so you just, even though it's just a row, you subtract components. 3 minus negative 2, 5 minus 11 is 5, negative 6. And lastly, C, they're not the same size, so not possible to subtract. Now, in addition to adding and subtracting matrices, we have multiplying a matrix by a scalar. For scalar multiplication, if A is a matrix and you wanted to multiply, say, 6 times A, you simply multiply every element in A by the number in front. So that would take the 2, 3, 4, 5, 6, 7 and multiply them all by 6. So computing the following, 12 times that matrix, we just multiply every entry by 12. 12 times negative 2, negative 24, 12, 36, negative 84, 0, and 24. If you want to multiply everything by negative 3, again, you just multiply every entry by negative 3. Negative 3, 12, 0, 0, negative 6, 21, negative 15, 27, 3. And even fractions. I don't know why I made that big. The row times 3/5. 3/5 times 1 is just 3/5. 3/5 times 5, the 5s will cancel, it's 3. 3/5 times 9 is 27/5. And so these three operations are basic. They're everything that's in this section. So one thing to note, The zero matrix is just a matrix with all zeros entered in for all elements of the matrix. It could be any size. And this is the additive identity matrix. So there is an additive identity in a matrix. It's the same size as whatever matrix you're talking about, and it's just zeros in all the entries. And there's a few properties. Commutative, doesn't matter the order in which you add them because our natural number system is commutative over addition. Associative property, doesn't matter the order you add them if you have multiples. Adding the zero matrix to a matrix leaves it where it was before. And adding the additive inverse of a matrix gets you to the zero matrix. And lastly, A plus negative B, so multiplying matrix B by -1 and adding it to A is the same as subtracting, because again, these all are based on our actual number system. And that is all in 6.4.